Hey everybody, I'm Brian Axup. I work at Esslinger Engineering. We are an engine builder. Imagine that on Engine Builder Magazine's Instagram. Anyhow, our main focus for a lot of years has been the Ford four-cylinder single overhead cam engines. Been working on those since early 70s, and over the past 10 years, we've started to branch into other things, especially once COVID happened and our state government, we're here in California, our governor decided to say that we are not a business that could stay open after they shut down our state. So we had to sort of figure out some other avenues to bring in revenue streams and whatnot. We were closed down for 8 weeks. After the 8 weeks was up, we were way behind, as you can imagine. We basically produce about an engine a week out of our shop. We have 7 employees. We're a manufacturer as well as a builder. So we manufacture our own aluminum blocks, cylinder heads, manifolds, pulleys. As you can imagine, that requires some machinery. We have a few different CNC machines, lots of conventional machinery, but ultimately we only have 7 employees, so we're not capable of putting out a whole lot more than about 2 engines a week when everything is going well and we're kind of doing the same sort of engine over and over. I see a bunch of you guys are joining in. Thank you for checking out this takeover. Thanks to Greg Jones for inviting us and everybody at Engine Builder Magazine. Let's start off with a little bit of history. So our company was founded in 1968 by Dwayne Esslinger. And for, the next, 44 years, it was a family-owned business. So in 2012, our company was bought by Bill Buckley. He was a customer of ours, is a customer of ours, and has a midget team. They are in New Zealand. They're based in New Zealand. They also now have a team here in the U.S. as well for midget racing. So circle track stuff for all of you people that aren't aware of what a midget is. It is a little bit smaller version of a sprint car. It's got 4-cylinder, normally aspirated engines. They're purpose-built. We manufacture a single overhead cam engine. We have quite a few different variations. Originally, we had what was just called a midget engine. Then we progressed into what then became known as an ST, so like a short track engine. That really wasn't named ST until we had a TST, which was a titanium short track engine, and an XT, which was a little bit later variant that had taller cylinder heads, so more raised up ports, bigger intake valves. The valve locations were a little bit different, but that happened in, like 2003, 2004, somewhere around in that area. We started making the XT engines. And fast forward to about 2008, we, at the prodding of Bob East and some of our other customers, Western Speed at the time, the guys that were all running like Vital Express, that whole deal, kind of wanted to push towards having the intake on the inside of the car and exhaust on the outside of the car, like the pushrod engines had it at the time. So we made what was called the RSI head, so right side intake. That was the latest version of what was ultimately based on the single cam Ford. So the engine that came out in 1974. It was a cast iron block, cast iron cylinder head. Over the years, the Esslingers developed it, and kind of when they wanted to go midget racing in the 90s, they developed an aluminum cylinder head for it, then later an aluminum block. And that progressed all the way up through till about 2015, when the decision was 2016. So then the decision was made to start a development of a new engine, what we now call the BB7. The BB7 is a bigger bore spacing engine. It is, as you can imagine, we're cubic inch limited in midget racing. So we would have 161 cubic inches, rev limit of 9,800 RPMs. That's what USAC, the sanctioning body, limits us to. So we developed this big bore engine. So we went from an old bore and stroke combination for the same cubic inches with the RSI would have been 3,934 for the bore and a 3,300 stroke. That made us just a touch under 161 inches. So once the BB7 was developed, we moved up to a 4-inch 65 bore and a 3-inch 75 stroke, and then along the way increased the bore again. So now we're at 4-inch 125, and we've had to reduce the stroke to basically 3 inches, 2-inch 995. So that way we could stay under our cubic inches even with a small overbore, so we can service the engines, go standard 5 over, 10 over, not have to put sleeves in on the first rebuild. So now that there are bunch of you watching, let's take you guys on a shop tour. So I'll show you kind of our machinery, where we work on the stuff, kind of the order that we do things as an engine comes through the shop, and some of the other projects that we have going on here. And then we'll kind of come back into the engine room where I'm at, or assembly room where I'm at, show you some of the different engine families that we work on. So let's see, let's turn this thing around and we'll head out to the shop here. So let's see, I'm a little new to this if you haven't noticed, so let's flip this thing around. Let's walk on out here to the shop. So walking through the shipping area, we're going to go out to our shop area. So ultimately back here in the back, hey Raul,
how's it going?
Let's show you guys where we start. So engines will come in, and they will come in, look something like this. This is an RSI, got dropped off on Friday, and we have a BB7, an Ecoboost, and an XT. Oh, now we just got our air compressor that decided to come and play. So what we have here, hopefully you guys can hear me. We have our teardown station. So this tree has 4 different engines. So what we have is a Lamborghini 5.2 liter V10 that we do for Sheepy Race. We build their engines. We do a couple of different stages, and so whether they're sleeved, not sleeved. This would be a lightweight BB7 block. As you can see, there's a bunch of pocketing. It's a billet block deal. This is a cast aluminum block, which is for an RSI, for Rusty Carlisle, Brody Fusion. They're here in California. We have an aluminum 2-liter block, 2-liter Pinot, like for the Europeans, and some road racing stuff. Basically classic engines that are still in the works. We have here a block that was repaired. Another engine builder takes care of this one. but they sent it back to us to get fixed. So you can see the repair in it. Still needs to get body worked a little bit on the outside, but this is our align bore machine that was custom made for us. So we align bored the mains. Now it's ready to go over and get a line honed. Everybody has one of these, or should have one of these. So this is a Winona machine. It's like a drill press, but you can use air and move the table all around. So basically we'll see if I can show you. See this, everything moves around with air pressure to hold it. We have a suck bench basically with a bunch of lighting for hand porting, blending valve jobs, that sort of thing. Crank grinding machine. We have a Sunnin VGS 20 that we use for our valve jobs, and we use their DCM's machine, CBN, for surfacing. Someone's asking if we weld the blocks. That one that we repaired, yes, it was welded up. It had a hole in it from a rod trying to get out. It's kind of what happens sometimes if they have component failure. I mean, we turn 9,800 RPMs with that engine, sometimes over 10,000. We're limited to 10,300 RPM. So things go fast. Sometimes they go boom. Nobody likes it, but that is what happens. So next is our SV10, our cylinder hone. Pretty common machine. A lot of you guys use it. We use diamond, what we would call a stone, and plateau brushes. One thing that's a little bit different, we do hot honing. So we have a hothead engine heater, and it's plumbed through. You can see the hoses down here. They would plug into the block, and then we have specially made torque plates that run coolant through the block, and that way we can get everything up to temperature, so everything would be 170 to 180 degrees when we're honing. That way cylinders have grown to the size that they will at operating temperature. So we may hone to 6 thou hot, which 6 thou piston to wall clearance, depending on the application. That may only be 4 or 4.5 thou at room temperature, where everybody would typically measure things. So another thing that is kind of a unique thing for us, so this is our align hone setup. So we can bolt a cylinder head. We do single overhead cam, and we can bolt a block. We bolt them onto this little deal here, and we have this everything on a counterweight. So all the weight is vertical, so we don't have to worry about the weight of the machinery affecting the main line in a block or the cam tunnel in the head, and kind of worrying about making it go like a banana shape. So doing it vertically, there is nothing but straight up and down on the thing, and it allows us to keep pretty good. We're within a couple of tenths on every block and every head. So that can be done with it horizontal too. Just takes a little bit more finesse, someone with a little bit more understanding. We have a rod hone, little parts washer. This would be our washing bay, so that we can wash all the oil and grime, soap off of everything, and it can get reclaimed. So when it's done, it goes out to our evaporator outside, and then it's heated up, so it steams off the water, and then what's left is all the muck and grime and everything that comes off all the parts, and then that can be scooped out and sent off hazardous waste. So that's one of the requirements of what we have to do in California. Have a big screw compressor. So typically the engines will come in, they'll be in a crate like this. And so this is a Lamborghini V10, a 5.2 liter, like the Huracan engine, or an Audi R8. and it's ready to go out to our customer. They'll come and pick this one up, drop off another one, and kind of start the routine again. So over here you'll see carts. Carts are how we keep track of everybody's parts. So you can see Carlisle, RSI. So that earlier I showed you their block on the stand. This is the rest of their parts. Each one of these carts is a separate engine. So a bunch of blocks, and our Coyote engine, that's a dyno mule we use for testing. Another 5.2 Lambo for use as a core. It's missing some timing components and whatnot. Just a core that got sent in. A bunch of other blocks. So here's a kind of unique thing. We do sleeving on these Lambos. So you can see this one was cut for a shouldered sleeve. That would be a factory block next to it. Both of them have a hurt cylinder wall. So this one was machined, and then we found a cylinder wall that had a crack in it, so we choose not to use the block. That way we don't have to worry about any leakage or anything like that. Let's see, over here we have on our big CNC machine, we have a cylinder head that's going through getting ported. It's already been ported and run. Now it is during R&D, you know, you're trying something different. So right now the port's getting reshaped slightly. So you left the doors open so I can kind of show you guys what we got there. So that would be a pretty cool thing. See, 5-axis CNC porting. We have a small mill that's used for brackets and pulleys and stuff, and then this would be a lathe, our little SL20, and we do anything round on there, so pulleys, that sort of thing. Like I said, each engine gets its own cart, so you can see on these carts they would have a tag that shows kind of what the engine is and what's different about this than maybe a standard deal. So you can see on this one you have 3mm oil rings. Check this out. So this one, everything's the same except the pistons have 2mm oil rings, and so we have to keep everything separated. Once we're done tearing down an engine, it'll go on here. The rotating assemblies are already on these carts. They just have been balanced now, and they are ready to get assembled. These are our aluminum blocks that we make. So for an XT, an RSI, TST, and ST, these cast aluminum blocks. They're not billet like the BB7. These are a little more cost effective. This is what we all ran before. Let's see, kind of show some other stuff around here. So we have our crankshafts. This would be our row of cranks. So up on the top would be 2.5 liter Duratec. Then we have a bunch of Ecoboost. There's a Lambo crank on the end. 2.3 Pinot. Single overhead cam down here. Midget. These are BB7 billets that we have here. And those are done on the machine. So the machine that's doing the porting, that would be where these get machined as well. And you can kind of see the finish on them. They're all the machining marks, so they'll go to polish next. After polish, they'll get core heat treat, and then ground, and then final heat treat, straighten, balance, all of that. So sounds like they have fired up the engine dyno. So let's cruise over and see what they're up to over there. So you can see that's a BB7 midget engine. It's a 161 and it's a right side intake, so when you're sitting in the seat you see the intakes on the right side or inside the car. Maybe I'll open the door and show you real quick kind of what it looks like. And so let's back this out. Hey Case, can you make another hit on this?
Yeah.
They'll like to hear that. A partial hit. Everyone likes to hear the sound of the engine, right? Pretty cool. That thing will be at the Chili Bowl racing here in January coming up. So let's, I'm walking in here to our assembly room. So let me turn the camera back around. I will turn this around so I'll show you, kind of walk you through some of the engines that we work on. So what we have here is a 331 cubic inch, so it's a stroke and big bore, so it's sleeved. We've sleeved the block. You can kind of see the sleeves that we do and the high compression pistons that we've had made. So these are a billet piston from Racetech. It's got Carrillo rods, it's got a offset ground factory crank. They're a forged crank in it. And then it's in the process of getting these GT350 heads, getting the cams all degreed in and everything. What we have here would be a drag race turbocharged BB7, so it's our billet block 4-cylinder. It's going in a dragster in Australia. The Andersons are a real good customer of ours. We've built them 4 or 5 engines over the years that they run in drag racing in Australia. You can see the 5-stage pump on it. It's got low compression pistons. So this engine had to be at least 185 cubic inch. So we built this and it is a 189 cubic inch. So they could move up a class and not have to race against their other engines that this will go up into the next higher cubic inch class. But in Australia they wouldn't let them run without the thing being at a minimum cubic inches of 184. It had to be to move up. So this one is 4-inch 145 bore, so it's bigger than our midgets, and it's a 3.5-inch stroke. This engine here would be a Duratec. It's a 2.3 liter Duratec that we're building for Shane Knight. It's kind of a unique thing for us. This thing is all stock. Everything has to be factory for the Carolina mini stocks. So we just kind of gone through and made sure everything is in good shape and fresh. So it's got a factory forward piston, a factory forward rod, factory forward crank, and so on. You can see there's no oil pan on it. We had to modify the oil pan to work better for controlling oil in the circle track. So we fabricated a pan. Now we sent it over to a partner shop of ours to have them duplicate it. That way we can produce them for other customers. We have here a Ford 2.3 single overhead cam. This one races up in Michigan. It is a roller head, and let's see, let's cruise over to the other side here. So we have another, this one's a 2.9 liter turbocharged engine going to Bonneville, single overhead cam. See the motor plate, front motor plate on it that's kind of unique. We have here a 2.3 liter Ecoboost, kind of tell what it is. So this block is unique. It's a semi-closed deck, and it's got our pistons that are made for us by Race Tech. They're custom made. We've kind of worked over and over the years with JE and Race Tech and kind of have our own spec of pistons. You see the fuel bowl in it. Has custom made 625 plus head studs that are going with it. That'll be a complete build going in a Focus RS. It'll only be around 500 horse engine. For the guys that are making a bunch of power, I'll show you in a little bit here. We're working on a billet block for the 2.3 liter and 2 liter Ecoboost guys. So right now we build the world's fastest Ecoboost. Mark Lelchuk, he has run 920 at 149 and in the 920s. So he has split some blocks though, trying to get after it. That's what the Ecoboost blocks. So they split in this area right here that they end up cracking, and they lift the head studs, and the cylinders end up lifting off of the main part of the block. So we're building our own block, a billet one, where we can add material and eliminate those problems. So have in the late spring we'll have some guys running those that they'll be a little over 1,000 horse. Right now they're a little over 800 on these blocks, and they have to be careful with the tune and everything to kind of not make too much power too early. So let's move on over to this one. So this guy's Yo Cutla. It's a 2.4 liter road race Duratec going in an NX5. It's 12.5 to 1 or 12 to 1 compression. It's going to get a CNC ported head and set of our stage 4 cams, so you can kind of see that. Zoom in. We CNC port these heads. We also do Coyote heads and 6.2 liter, like what you'd find in an F-150 or a Raptor. So let's move on. So this would be another 2.4 liter for Eric Houlihan, and this one's on ITBs. They're kind of a unique setup. They're really small, 45 millimeter. These engines really like a lot bigger, 50 millimeter, 55 millimeter. But this one's got 45, and they're drive-by-wire, so they use a factory throttle body. They use a factory throttle body there, and they are driving the throttles from that. So we just got this back. R&L killed the thing in shipping. Broke the valve cover, broke the air cleaner plate, damaged it inside a plastic crate that it had 6, 8, 9 inches of room all the way around it, bolted down to a stand inside it, and still somehow they managed to damage it. So he shipped it back to us so we could fix their damage, and we ended up putting on one of our new fabricated oil pans. So let's cruise in here. We'll see. Let's see what Casey's up to. And this our boss. He's probably working on some CAD stuff. Hey, Case.
Hello.
Hey, let's see what you're working on here. So
The billet block for the Duratec Ecoboost.
So let's see.
I'll show you what I'm starting with here. So I basically start with, this is the model. I'm sure that Brian showed you guys out in the shop. I'm starting with the 2.5 actually, and I'm gonna adapt the 2 liter Ecoboost pickups and clearance for the turbo and make it so it's a universal block. Also what I'm doing is beefing it up and making it so it's 1,000 horsepower plus without blowing the head off of it and the head studs and everything else. And kind of my approach that I'm taking at the moment, I'm still in its infancy, but so you can see kind of what I'm doing here. I'm just starting really simple and picking up all the crucial areas of it and gonna add material where it needs it and get rid of it where it doesn't. This is not so much we're going for something to be lighter, but we're going for it to be stronger. But you can see if I take this away, how simple I'm starting with. So this is just basic building block of it, and then as I go through and get the simple version of it, then I'll go and start to lighten it and pocket and rivet, and but you can see like right now it's just a big block. The other thing, when I'm designing something, since I'm also the programmer and machinist, I like to think about designing it how I can actually make the part. So a lot of that has to do, like, if I pull this radius, I know what size tool I want to use. So that's just doing like that right there. You can see that it makes it look quite a bit different. But that'll all be done at the end, and that's mainly cosmetic, a lot of that. But so that's one thing I'm doing. The other thing I got going on out there is I'm porting a cylinder head on our EC1600. This program I'm using here is ANSYS Space Claim. That's where I do all the design work in this software, and then all the programming work I do in Mastercam. And we have a custom post built specifically for the machine with some custom tooling we made. So this is a prototype cylinder head I'm working on, and you can see I can run it in a simulation before I actually run it on the machine, to avoid any potential crashing, what we call crashing, when this hits the part in a way you don't want it to. So you can kind of see here, and it'll give me a report how long it takes, because I can judge a lot of times if I have something wrong, if it takes too long or it's too short. Just kind of common sense from having experience, but you can see it's very accurate. As long as I have all the modeling built into the simulation correctly, it's very accurate.
You can see it's simultaneous 5-axis, the way that it's machining, the head's moving on constant motion. What was the other thing? It looked like you were doing a flow simulation on a stack.
So what I'm doing here, to give you an idea of what my day's like. So this is a head that I tested on the flow bench, and I also tested in simulation and on the dyno. And I've had some ideas since then, and one of the ways I can test my ideas is through, it's called Discovery Live, and I can actually make changes live, meaning that if I'm not going to show you guys my port, but here's something that we do. You can kind of see.
So that's a velocity stack.
Yeah, so this is a velocity stack, just to give you an idea of what it can do with anything, fluid dynamics, period. And I can make changes to this and then rerun it through, and I have to set the magnitude and flow velocity, and I can see if the air speeds up. And right now, how I have it set, let's give it. There we go. So if you look over on the scale over here, it's telling me the blue. All I want to see is blue. Blue means that the air is moving fast. As you go up this chain here, that's the air slowing down. And but what I can do is just to simply show you guys. So you see this radius in the top right here. I want to see if that change in that radius is going to change the airflow. So I just go in here, and I'm going to tighten that radius up. Went to a 1/4 inch radius. Now I'm going to rerun the simulation. And I can see what it does. Not only that, I can spit out a report too of it, of my results.
Cool.
So it's just one of the tools we use. And then, so what I'm doing out here is after I ran that simulation on the changes I made, now it's time to actually remove the metal. This is what you saw in the simulation that I had in there, the machine simulation. So this is all custom tooling. Bill, my boss over in New Zealand, made this plate for me. It had this bottom plate, and then we put this rotary on here, and I made all this tooling so that I could port cylinder heads and manifolds and whatever I need to. So I have full simultaneous 5 access with this machine now. one thing that's different about us than a lot of other places, that I can sleep on that and come in the next morning and make a change without going through any red tape, which allows us to use our creativity instantly. It's nice having these tools at our access.
Cool. Well, thanks for showing us kind of some of what you work on, Case. All right, let's walk over here. We have kind of something else that's pretty cool that we got coming up here. So we have, you can see it's a billet block Lamborghini 5.2 for cheapy race. Maybe we can hit 3,000 horsepower with it. So it's going in turbocharged deal. Every engine that we build for them gets turbocharged. Let's roll back over here and see. Let's cruise in, show you guys kind of, this is our parts area. So see if I can back up enough. So we have pistons, rods, manifolds. These are a bunch of different fittings, head gaskets, different selection from Cometic, all of our valves. So we have Manley, Del West, they're our partners on most of this stuff. Injection parts, a bunch of Coyote parts and pieces, different valve train, valve guides, valve springs, Ford 2.3 single cam stuff, from timing belts to adjustable cam gears. You can see different square tooth gears. So this is the outer part of the cam gear. And let's grab an inner, show you guys kind of how it would go. So this inner would go in here, and that's how you would adjust the thing. So you can see we have square tooth, round tooth, and then wide round tooth, which we are out of at the moment. We're waiting. One thing we don't do is hob the teeth on them, so we are waiting on another partner company of ours to finish hobbing the teeth on those. We do things like billet heavy duty tensioners. So this tensioner, the stock ones are a multi-piece, and sometimes the pulley on them comes off. So years ago we learned how to do these. So we make a billet plate, steel plate, and we're unique in that we thread them in and we weld them so that they cannot come out, where everybody else rivets them, and the rivet is one of the main failures. So we have quite a bit of unique stuff. Let's see, anything. Oh, let's show you guys our parts room, where like how we stage new builds and existing builds and stuff that we're in the middle of. So we have a room here that has a bunch of carts in it. So let's walk down here. Each one of these totes is a engine, the Ecoboost engines, and then these carts are an engine. So you would have each one of these, so there's a separate cart on each one. This is turbocharged, the black engine in the engine assembly room. So the black engine in the engine assembly room is this one. You can see the turbo, header, ignition. So he runs in a classic class, and it has to be carbureted, has to have a distributor. So it's a little bit unique for us. We have a BB7 that's here for a rebuild, one of the Team BSL engines. We have a Duratec 2.4 liter, well, was a 2.5 liter that got starved of oil with a stock oil pan in a road race car, so it's here to get fixed. And in the process, we're going from a 2.5 liter down to a 2.4 liter, so we can rev it up a little bit more, as well as putting on one of our newer fabricated oil pans to control the oil better. Here's Shane Knight, that's one of the engines you saw. Here's the drag race BB7, so you can see it's a 80 millimeter billet Garrett 4709R. It's a GTX 4709R. In Australia, they have to have a blanket on the compressor. So in the US, we don't have to necessarily have the blanket on the compressor, but they have to have SFI approved exhaust housing, which this has as well. Another thing on it, it's got a Hogan's intake manifold, so it's a billet intake manifold. This one's going to run mechanical injection, so on methanol. So you can see 8 nozzles. It's got primaries and secondaries. We have another Duratec, drag race Duratec that we're building for a customer to run in super stock modified classes. 2.3 liter single cam Ford. These are some cams that we need to process and get ready, get finished. So they've been ground on the lobes, but they need to get marked and so that they have the identification on them of what they are. So we'll know, like this top row is stage 4s, then we have stage 3s, 2s, and 5s here, and then a few more of the MX5 oil pan, fabricated oil pans. So hope you guys liked the walkthrough. Kind of unique stuff. A lot of people really like these trees that hold the engines, so we can hold it 4 engines at a time on them. Makes things a little more efficient. So anyhow, well, hopefully you guys enjoyed it and you got a little bit of an idea of what we do here at Esslinger Engineering. And thanks to Engine Builder Magazine for allowing us to host an Instagram Live for them. And you guys should keep checking out their page and give it a like. And later they will be uploading this video to their YouTube channel, so check it out.